thank you for joining. I'm Emery Brown, and I'm the marketing director for Green New Energy Materials. And as I mentioned at the main stage, we are a high volume manufacturer of lithium-ion battery separators. And I'm just going to talk to you a little bit some of the manufacturing challenges and some insights into lithium-ion battery separators. So we are located in Denver, North Carolina. That's right outside the Charlotte area. If you're familiar with the Charlotte area, it's up by Lake Norman. We do have a manufacturing footprint at the facility, 534,000 square feet with production lines. When we get total capacity, we'll be at 20 production lines in the future as we scale with the growing market demand here in the U.S. Projecting job creations about 500 plus with over $1 billion economic impact over the next decade to the state of North Carolina. Always like to show a little bit about the facility. We were founded in 2023, but we are part of a global expansion. I'll talk a little bit more about that here coming up, but I do like to show that we are a true manufacturer. We do have a facility. And just last late October, November, when we first got our offices complete. So we got kind of a nice, beautiful office. If you are at Battery Show South and next week, feel free to sign up for a facility tour. You'll get to see our kind of state-of-the-art manufacturing facility. We do have a viewing hallway, slurry production department, separator production, of course, QC lab, slitting, so we can slit to all cell sizes and formats. I'll discuss a little bit about that in one of the later slides, well as our packaging and shipping department. And that's kind of one of the challenges that I will be discussing here soon. So for production capacity, we are in the process of scaling. Over the next few years, we intend to scale up to about 20 production lines. With that, our capacity for separator can go. We project being going upwards over 2 billion meters squared. So very high volume production, and we are moving towards that as the ESS market grows, along with EV. And those are some setbacks right now here in the overall market, but we do see better days ahead for both industries. So we are projecting that growth. And just to be clear, we are part of a global expansion. So we do have a parent company in China. While GNEM is a U.S.-based company, our parent company has also expanded over in Europe and Sweden. We have a manufacturing plant there. We do have R&D in Germany. We have in Malaysia, the first kind of battery component manufacturing in all of Malaysia. There we have a massive facility there. So R&D in Japan, and again, just a lot of manufacturing over in China. I will not go too much into discussion on that today, but just want to give you a full kind of a global layout. As per our parent company, we do have many strategic global partners throughout the world, such as LG, BYD, Eve, SK. So you've probably heard most of these companies. We do work with many of the big players in the battery manufacturing market. So I'll just kind of jump right into separator, fundamentals and get us into advanced separators. And I always like to start off with, how we think of separators. And a lot of people just kind of have the vision when it comes to battery what a separator does. And, it provides a separation barrier between the anode and cathode and allows ions to migrate across. And that is very true. That is what it serves its purpose. But, today's separators really are, I would say, much more advanced than that. They're there to help regulate concentration and voltage gradients, mitigate temperature gradients and thermal runaways, lower internal resistance and help block the dendrite growth to enhance cycle life. And so overall, we focus on the separators to enhance safety and performance, again, extend cycle life and calendar life, and enable fast charging and higher capacity utilization in the electrodes. And really, all this is accomplished through really advanced coatings onto the separator. And that's where GNEM is focused on. That's what our core was, what we do at our North Carolina facility is to do advanced coating onto base films for the lithium-ion battery. So we are bringing so a lot of this advanced technology to the U.S. market. So I like to use this opportunity to really kind of also break down real quick. When we talk about separators, we often hear about the terms dry and wet separators, and a lot of people kind of have a misnomer when they hear, "Oh, wet separators," it must be physically wet, and that is not the case actually. So when you hear these terms, they're all about the way they're processed. So when we get to the dry process, what we're looking at is really a separator, a base film that has been processed through dry extrusion. So really, you get the polymers and the resins mixed together and dry extrude it, anneal it, stretch it, and this creates pores. This is really the traditional way of doing base film manufacturing for separators. It's really the key advantages. It does have the lower cost, but it also has other advantages with higher porosity, which kind of can lead to help with faster charging, better structural control, which is great for uniformity, and high compression resistance for safety. Of course, the wet process of course, involves dissolving the polymers and resins into kind of a solution, and that is extruded out. That solution is extruded out into a thin film, and often it uses a very high boiling point solvent, which is then kind of replaced with a lower boiling point solvent, which is then evaporated out to leave the pores. And its key advantage is better performance. It usually has a better wettability. This method can also do lower thickness, higher isotopic strength, which is great for high volume cell manufacturing, and higher puncture strength. So both of these offer some advantages and disadvantages. One thing I will say about wet process is that more and more the industry is adopting wet-based separators. The cost of this manufacturing process has come down, and it's getting much closer to the dry. And so it is slowly, I would say, taking over the market in terms of separator base film on there. Here at GNM, we offer both, and we can offer in various thickness range and quite a large thickness range. And different porosities. And that thickness range, I'll get really to why that thickness range is quite important, actually, and why we don't always want to go super thin. But we do offer that. We have multiple series of different options, and we have a good number range of different base film options. And then our separator coatings. We have four categories of coatings. I'll go in these just a little bit in detail here, but ceramic coating, polymer coating, membrane composite, and of course our membrane functional separators that we do the coatings onto the base film. So ceramic coating series, most of what we're looking at is the alumina, bohemite, and there's others in here, but these are the main coatings. And it's really all about thermal stability, increasing high strength and thermal stability. That is where these ceramic coatings come into play. We have low moisture content and resistance, low thermal shrinkage, and of course they can come as some small particle spheres or kind of nanofibers. But the ceramic line is all about enhancing safety of the cell. When we look at polymer coating series, we work with a variety of polymers. PVDF and PMMA are the most common. We do have some others we do behind the curtain, if you will. We can do water-based for economical, oil-based for enhanced safety. But really, the polymer is really what we call the adhesive. It's meant to put on the base film, and it serves as an adhesive, if you will, for the electrodes. So its goal is to actually lower the internal resistance, and it's great for fast charging applications on there. And I'll show a little bit about that here in just a few slides. We have to get that actual coating coverage optimized. If you go too much in coverage, you actually wind up getting high resistance, and you actually cause the problem you're trying to solve. Too low, same kind of thing. You don't really get much benefit to it, causes problems. So, polymer coatings are pretty popular with the fast charging applications. Of course, we got membrane composite series, and this is really a combination, if you will. We typically bring together the alumina, bohemites, PVDF, PMMA, and make a kind of a composite membrane. And it's designed to take advantages of both the ceramic and polymer. It can be true composite films, but more often than not, you're looking at either ceramics on one side, polymers on the other, or polymer on top of the ceramic, creating what we call the top coating. I'll show you that a little bit on the next slide. And our membrane functional series, these are more of our most advanced coating options that have come to the market, slowly being adopted, and they are designed really for high performance and safety. We do have a number of advanced coatings in this series, but the two that we publicly put out is the LATP. That's a solid electrolyte coating. I'll share a little bit more about that, but for LATP, it's an ion conductor. So it can help with enhancing safety. The armament is really a synthetic fiber, kind of helps create like a skeleton fiber around the base film, and it's really good for high temperature applications. So it is a growing popular product, if you will. We do have a variety of different coating options in this, and you start with the base film and GNEM. Oh, so for we start with the base film, and we can do multiple ways of coating. We can coat on one side, double-sided. We can do polymer on top of the ceramic. We can do double coating, double-sided. We also have to do some hybrids for ceramic on one side, polymer on the other. So mix and match and a number of different coating arrangements, if you will, onto the separator. And we do serve the electric vehicle and ESS markets. We can do cylindrical cells or prismatic cells. We can really do any format, if you will. We start with the base films, and we can do the resistance, like I said, the ceramic resistive heat resistive coating, or kind of the adhesive coating, or kind of a mix on there. So I think that's about it for the fundamentals of the separator. So I'll go ahead and I'm gonna move really into the key challenges, if you will, for the separator manufacturing. And I've got a message here. Okay. So I'll go ahead and begin with uniformity. So this is one of the big challenges, and really when we talk about uniformity, I want to bring up kind of the word consistency in here. So I did mention earlier about 2 billion square meters per year when the project is at completion, when we are at the full build out. To put that into perspective, that is about 772 square miles of separator. I also like to, and really it comes out about 372,000 football fields. That's a lot of separator that can theoretically be produced at full capacity in here. Just disclaimer, we are not manufacturing at that scale yet, but there are facilities in China that are manufacturing at such a scale. That is how much that just kind of, but I just want to give you that perspective on what that looks like. And contract orders can be from hundreds to over 100 million meters squared over a certain period. Those are pretty large contracts. That's a lot of material. And for separators, there's a lot of parameters really that really go into this. You're looking at base film thickness, base film porosity, the base film Gurley value, mechanical strength, tensile strength is important, isotropic strength, puncture strength, and the coating thickness, coating coverage, and moisture content. Those are just some of the few. There's quite a bit more, but I just want to highlight some of the big key parameters that we need to keep consistent across these large orders. on there. And so, um, non-uniformity, it actually, what it does is it jeopardizes performance when we have non-uniformity creeps up. This ultimately, when it gets to our customer, non-uniformity causes winding or stacking issues, increases in scrap, increases wetting time, and ultimately increases manufacturing cost. And that's not a good thing for us or our customers. So, uniformity is a very big key, if you will, in separator manufacturing at such volumes. And the kind of key takeaway I want to put on here is that the separator does have a really higher threshold for uniformity, if you will, than a lot of the other battery components. You can get away with a little bit of variations in your cathode materials, your anode materials to a certain degree, but separators are very difficult to get away with uniformity issues. And I'll just provide a quick case study real quick on uniformity. And one of the problems in separator manufacturing is how PVDF, the polymer, was put onto the base film. It's always typically been applied through a, a spray coating process. And not only was this hazardous to employees, dust and everything else, but it was a very non-uniform coating, as you see on the bottom left on there. And this often caused cell winding consistency issues. Now, in the past, it wasn't so bad, but as manufacturing today has gotten these high volumes are very fast in manufacturing and cranking out cells. This is becoming an issue in here. And late last year, our parent company publicly released this once proprietary, but now public information proprietary spot printing process where we apply micro PVDF bumps onto the base film. And we control this bumping, as you can see right there in the middle. And you can see how much more uniform and how much more consistent those bumps are. And this process is, of course, environmentally safer, it's friendlier, just more compatible with today's automation and high volume manufacturing. And ultimately, this has led to reduced cost and reduced waste. And here, so it is one of the products the company is quite proud of when it comes to polymer coating on there and being able to bring this kind of technology to our customers. The next challenge I will kind of go over is quality control, and quality control is a real big one, if you will. So when we talk about quality control, really what we're saying is we're ensuring design and material composition meet safety and performance requirements. Um, I had to give it a little bit of thought on how I wanted to share quality control. I didn't really want to bore everyone with a bunch of with a bunch of data to show low levels of impurities or anything. So what I did want to do though is maybe bring up this question. Um, and that is, are lithium-ion battery and lead acid battery separators similar in this? And I think a lot of people, even myself, really did not fully understand this till just a few years ago, um, how similar they really are. Well, I like to make the analogy that just like football and ice hockey, they're both team sports. Well, they're both separators designed to physically separate the electrodes and allow ion mobility, but that is really where the similarities end. And in case you're wondering, yes, I do live in Kansas City, so anytime I get to put Patrick Mahomes in my presentation, I'm going to do so on here. Um, but maybe I want to share a little bit more about this quality control and just the challenge, if you will, for lithium-ion battery separators. I just want to compare them a little bit to the lead acid separators. And just know I'm not a full-on expert of lead acid separators, but I can discuss them kind of at a high level. So this is where we can discuss. I think these first four topics, a lot of people in the battery industry are probably familiar with. For lead acid, you're looking at a lot of the core materials such as glass fiber, PVC, rubber, cellulose, etc. When you get to lithium ion separators, you're looking at the polyethylene's base film, such as PE or PP, and with the advanced coatings on it. Typical thickness, you look at lead acid battery separators are much thicker, often 100 microns or more. Whereas lithium-ion battery separators, it's designed to enhance energy density. So we got to get ultra thin, often in the range of 5 to 25 microns. Of course, the primary function in lead acid is electrolyte absorption and plate separation, but in lithium-ion, you're looking at ion transport with electrical insulation and enhanced safety. And kind of goes along with the performance focus of lead acid. You look at durability, reliability, and cost effectiveness, whereas in lithium ion, it's high energy density, safety, and cycle life. And I mean, those are just some of the few, many more, but I think you kind of get the idea here. But really, the complexity really gets a little bit more daunting once you start looking at other areas such as manufacturing complexity. And though lead acid separators do have their own challenges, the lithium ion separator, you're looking at needing ISO clean rooms, dry room conditions, really required to make battery operation. And this makes manufacturing these separators so much more difficult, along with the precise coating that GNEM does. So there is a manufacturing complex with it in terms of getting that quality right. Um, you know, Key safety features. Um, Lead acid needs to be acid resistance and lead dendrite mitigation. For lithium-ion battery, it's all about controlling thermal shutdown, controlling that and thermal runaway, controlling and regulating that, and of course lithium-ion dendrite resistance. Lithium-ion dendrite resistance is a lot more challenging, at least in my opinion. Why? We've never really solved it as an industry. We've come up with ways to extend cycle life. We've come up with ways to try to suppress them, but ultimately, lithium dendrites we have not successfully eliminated the dendrite problem. And many reasons for that, but just a very high level, what we can say is, these lithium dendrites are much more rigid. The size is down to the nano, so it allows them to creep through um, through grain boundaries and through porosity. And the speed of lithium dendrites, along with the lower thickness of the lithium-ion battery separator, just make it much more difficult and challenging to block, if you will. Um, and of course, the operating environment, lead acid, you're looking at aqueous and acidic kind of electrolyte. But in lithium ion, you're looking at organic electrolyte. But in the lithium ion, it's much more of a highly sensitive system, especially the lithium ion. It's just much more reactive, given its chemistry. And really, what this translates to is the purity. And this is really the crux of the quality control. In lead acid, you're looking at moderate tolerances. It still needs to be pretty low, under 100 ppm in impurities. But for lithium ion, you need to get sub ppm. You need to get battery grade for the metallic contaminants. It's got to be below 1 ppm. And the reality is achieving such a purity is really, like I said, the crux of the difference. And achieving such level does take years of development to get there, especially at high volume manufacturing. So this is a very big challenge, for any high volume manufacturing separator or really any separator manufacturing company for lithium ion battery is getting this purity right and quality control. Um, just a quick case study. I want to kind of back up just a little bit here and provide a case study on quality, on the quality controls. I say part of the quality control is enhancing the safety and making sure material compatibility and we can meet safety performance. A handful of years ago, multiple EV and battery makers came to our parent company and needing a solution and needing it fast. China recently banned EV battery packs or systems that catch fire or explode during or after thermal runaway events. It's set to go in effect in 2027. So it took quite a few years of kind of development to get this, but the solution was ultimately the LATP coating, the lysicon type solid electrolytes, lithium, aluminum, titanium, phosphate composite coating on there, and it's a lithium ion conducting coating on here, and it does enhance multiple areas. It really does enhance the energy density. It increases the energy, the voltage threshold, if you will. It helps minimize those side reactions that you might get with aluminum and bohemite at the higher voltages. So this coating is actually really kind of helped design to get that 5 volt goal that a lot of companies are striving for. Highly adaptable, and because of its ion conducting capabilities, it does reduce the required electrolyte volume, the liquid electrolyte volume. So that's another area where it helps enhance the safety of it. So this is one of our growing popular products for enhanced safety, and really for the semi solid battery customers of ours. Next, I want to talk a little bit about logistics in here. One of the major challenges that we see that we've encountered here, and I'll just go with the packaging, shipping, really, and storage, and really transportation, if you will. Um, First of all active lithium-ion battery materials have their own logistic challenges, especially when it comes to moisture on that. But separators have some unique challenges that I want to kind of bring to the table here. Um, First off, packaging. Separator rolls are cut to cell format for each customer, and this makes each customer unique in the size of their cell, what their coating is. In packaging, we can't just toss the separator into a box to roll and say, here you go. Each packaging design must be custom to really for coating compatibility and to prevent damage when it's being during transportation. We do take a lot of care in engineering packaging. And when I mentioned earlier on the introduction slide that we have a packaging and shipping department that is dedicated. We have engineers dedicated to just coming up with the packaging designs and sophistication to actually be able to deliver separators at high volume and big rolls to the customer safely. And another critical point here is that in the packaging, each design must be designed to really prevent dust. Dust is an absolute killer for separators, and so strategies must be in place when we go to packaging. During transportation, pardon me, these packaging designs do need to allow for continuous vibrations while in transport. Stacking is also a real concern. It doesn't matter how many labels you put on "Do Not Stack," fragile. They always seem to stack on top of that. Sorry, I go off on a tangent, but packaging can be real. Shipping can be really a bit of a challenge in here, and so we often try to minimize risk through full truck loads, and we want to do the shortest transportation times as possible, help minimize this risk of or damage in here. So when we do in the logistics and shipping and transportation of separators, we do need to focus on getting it shortest time and being able to get there because this is an area that neither us or the customer has any control over, and it's a kind of a risky time, if you will, for the product, and that's a lot of product that's being delivered at one time um, in there. And of course, storage. Shorter time in storage, the better, and that's true for all active lithium-ion battery materials because it poses the risk of moisture. But for separators, a lot of times it comes back again to the dust. Does our customer have the right storage facility to make sure that they do not get dust contamination in there and help to minimize or mitigate this? We try to get those separators when that manufacture high volume delivered on a strict schedule. So they're not just sitting around waiting endlessly to go onto the line. We try to kind of keep that feed going in here to try to minimize or cut down on the storage time. So I'll just move and really wrap up here with the last two, and this first is the technical performance. Um, and so I'll pose this question here. Is there a separate product that allows us to get everything we want in terms of performance? And as you probably know, the answer to this is no. In the real world, there are trade-offs, no matter what. This is just an engineering reality that we all face. Um, but the solution is really to prioritize performance metrics and find a balanced solution. And this can be often application specific. if you will. And I'll look at the two, I'll do a little comparison here between the two major markets, the electric vehicle market and the energy storage systems market. When you're looking at EV, of course, at a high level, safety and cost are paramount. People like to debate those. I don't. I like to say they're right there at the very top and equal in terms of for EV, especially when it comes to passenger safety. But after you get past that, what are the other important parameters? And this really does come down to the vehicle type and purpose. Is it for a high range vehicle? Or are you looking at lower thickness, optimized coatings? Are you looking for, is this more for a faster charging vehicle? Are we looking more at the lower Gurley values, higher porosity, and better engineered surfaces with the polymer coating and its interface with the electrode? Are you looking at value retention? Robust coatings, interface stability. Those all kind of play kind of a role in there. And what's the priority and what's not? Every OEM, every brand, every model is a little bit different when we work with our OEM customers. So we do work well with the OEM and their cell manufacturers to find that right balance that meets their needs. But for the energy storage market, it is a little bit different. From a high level, cost, safety, and longevity are the priority. So it doesn't have the variables that you will see in the EV when it comes to separate, but we know the priority, and those priorities must be balanced. And between cost, safety, and longevity, when we look at cost, it's no coincidence really that the ESS has really just taken off while the LFP, cost of LFP, has dropped significantly over the last few years. That's no coincidence. Of course, the AI build out is helping push that need for ESS, but when we build ESS, most of these projects are leveraged, and so they do require an ROI. And some will say, hey, cost might be even more important than an ESS than it is an EV. That's an ongoing debate in there. But ultimately, for the separator, though, that comes down to thinner films, lower porosity or higher porosity, kind of depending on your exact liquid electrolyte and whether or not you want more liquid or less liquid in there. And then safety. Safety, it kind of takes a little different turn than EV. In EV, of course, we're always thinking about passenger safety, but here in ESS, of course, we're talking about regulatory and insurability from that lens. So you're looking much more of mechanical and puncture strength of your separator, and of course, and then longevity. The longevity is, really the key to the ROI. Can we get cycle life? And and when it comes back to separator, this is about thicker films, more optimized coatings to be able to keep that longevity going, if you will. So we got to find the right balance between those three for the separator project and what's going on. So again, the GNEM team works, our technical team works really, really well with ESS integrators and their cell manufacturers to find the right balance between those three. I'll run one quick case study, if you will, for technical performance. A while back, we had an emerging EV maker requiring fast charging at about 5C, 12-minute charge to 80%. The problem is that they required an ultra-thin, lightweight separator, and their goal is to achieve 200 kilometers in 5 minutes. Now, this might be a little outdated now. Our EVs have gotten a lot better, but at the time, there was not a solution on the market yet for separators or for the separator to be able to handle this type of chemistry. And our parent company at the time came up with the solution to do a nanofiber coating. And so the nanofibers are about 100 nanometers in diameter coating with high porosity control. So they could be coated dispersed coating onto the membrane, onto the base film, if you will. And this ultimately allowed it to do the enhanced heat resistance, but also allowed for the high porosity that the customer is needing for that fast charging. And so this was actually kind of when this first came up, this was actually a big breakthrough for the company to offer this nanofiber coating. And today it's one of our premier products that are offered. Again, it allows fast ion conduction, high thermal stability. It's it greatly enhances the mechanical strength and the overall wettability, which reduces manufacturing time and cost into that. So, um, yeah, so I'll move on to the last challenge now, and that really is the cell assembly. And when we think about cell assembly from the separator side, we need to remember that there are multiple ways to manufacture cell depending on its format, whether it's winding, rolling, jelly, whatever you want to call it for cylindrical. Of course, you got stacking and Z folding for pouch and prismatic cells. I talked to you, I mentioned a little earlier about the thickness. You know, we always want, from a battery scientist perspective, we always want the thinnest film possible to get that higher energy density. The problem is that your separator has to match your manufacturing process. And we got to look at things such as tensile strength. This is critical, really, to speed and to the speed of the manufacturing and to reduce deformation. Um, and then, of course, thickness is critical to preventing wrinkling and tearing. And the puncture strength is also very critical, especially in stacking and Z folds, really to help prevent any piercing during assembly. These parameters are critical to balancing out this manufacturing. And I can't overstate this enough because unfortunately, when you go high speed, high volume, sometimes there's got to be a slight reduction in the performance metrics. It's very difficult to go high volume manufacturing and then try to put a sub 10 micron separator in that high volume and not expect to see wrinkles, rips, and tears occasionally. And, you know, this really does, this is a really big problem for cell manufacturers. And, you know, we call this, you know, the speed accuracy trade-offs. And this is, again, one of the major challenges that our technical team works with manufacturers to help bring designs for the separator to be able to meet their manufacturing challenges, if you will. And so again, it's one of the big challenges I would say in separator manufacturing. And just for a quick case study, we did have a battery manufacturer at one time come to our parent company. They had kind of an elongated cell design when they were doing their manufacturing. Their separator they were using was wrinkling during the process, and when they made the cell, it kept wrinkling and causing rips, and they never could get a good yield onto their during their battery manufacturing process. So this elongated cell caused some issues. Our parent company and the cell maker worked together and developed what we call the edge bonded solution. It had a PVDF selective coating right on the edge, but 1 2 centimeters on the edge of the roll. There, as you can see there on the right with the picture. And this was designed to bond with the outer edge of the current collector, with some of the exposed current collector. And when they designed this and they got this right, it rapidly improved their yield rate and improved their uniformity as well during their manufacturing. And it really enabled the high winding speeds and the enhanced safety on this. And so so again, this just kind of bring this back to the overall message I want to deliver here is that it's not just about technical performance. It's about getting the manufacturing right, getting the separator right to fit into the manufacturing. So we got to find that balance in there. So that's one of the big challenges. So I just want to leave you with a couple of closing remarks real quick, and that is, you know, GNEM is a high volume U.S. manufacturer of advanced lithium-ion battery separators. You know, we are a total solution provider for our customers. Our product portfolio spans 3,000 products with the 3,000 products spanning 4 coating series. We offer dry and wet-based films, serve both EV and ESS markets, and we are really the first high-volume manufacturer to begin operations here in the U.S. I know that there are some well-known manufacturers, especially one we share a city with. Great company. I think the key difference between us is just our sheer volume that we bring to the table. And by the way, if you are looking for jobs in the manufacturing sector, you know, please reach out. We do have a number of positions in our manufacturing process. So.